Hello everyone, I hope you're doing well. So in today's video, I'm actually going to go through the VCE Northern Hemisphere 2022 Maths Method, Exam 2, Extended Response Questions. Okay, let's go. So let f be this function, a part of the graph is shown. Find f dash of x, the derivative of x. Okay, 1 mark, so I'm just going to write f dash of x is equal. So I'm going to go on my calculator and define f of x. So define f of x as negative 2 over 5. So negative 2 over 5 x minus 2 to the power of 3 plus 3 over 5. 3 over 5. Okay, so we want to find f dash of x, so that'll be... Oops. Okay, this is your answer. So, let's write that. So, negative 6x squared over 5 plus 24x over 5 minus 24 over 5. Next question, give the coordinates of the stationary point of f. Okay, to find the stationary point, what we're going to do is we're going to solve the answer to equal 0, comma, x. So what our stationary point is at x equals 2. Now I'm going to find the y coordinate. So 2 to 5. So your coordinate is 2, 3 over 5. That is your stationary point. The graph of f has a tangent and a gradient negative 6 over 5 with x equals 1. The graph f also has a tangent with a gradient of negative 6 over 5 at another point D. Show that the coordinate of D is this. So we need to show what we can do, that we can solve, because we need to show, so solve f dash of x, so f dash of x. So we can say solve, okay, what we can do actually, so solve f dash of x equals negative 6 over 3, negative 6 over 5, so that'll be negative 6 over 5 for x, which would be, okay, so we're saying the derivative, which is this, equals negative 6 over 5, and we pretty much want to solve that, comma, x. So we get x equals 1 and x equals 3. Because we know 1 is already x equals 1, so the other coordinate, is... Okay, what I'm going to do actually, I'm going to show that I've done this. Okay, I am just going to go menu and I'm going to just factor. So I'm going to factor this over here with the respect of x. Okay. Alright. So if I bring this over here, and now it's a plus. I can, blah, blah, blah. So if we factor this, okay, we get this, perfect. So we can rewrite f dash, we can rewrite negative 6, x minus 3, minus 3x minus 1 all over 5, and that's equal to 0. Therefore, your answer is equal to 3 and 1. So, to find f, so your actual x coordinate, show that the x coordinate is equal to 3. So, therefore, x is equal to 3. Next question, determine the equation of the tangent that touches the graph f at point D. Very easy, 1 mark. So we're going to say y equals, okay, now go to this menu, go to calculus, and go to tangent line. With the function f of x, comma, at the point D, which is 3, we're going to put 3, which we get 19 over 5, or just rewrite this as negative 6 x over 5 plus 19 over 5. Next question. The tangent to f at point D intersects the graph at another point. Okay, I'm just going to... Okay, so we have a tangent x equals 3, which it's over here, and so it's going to look like this tangent. It's going to look like this, and it intersects another point which is over here. So the tangent intersects the graph of f at another point. The coordinates are. One way we can do that is, because we know the equation of the tangent, we can equate them. So we can say solve. So we can say solve negative 6 x over 5 plus 19 over 5 equals f of x, where x is equal to, so let's do that. So solve your answer equal to f of x, comma x. We get 0 and 3, but 0 is what we want. Okay, we want 0, where it touches the point at 0. So 0, so we know that x is 0, and we know that at f on 0 equals, f on 0 is 19 over 5. Therefore, your point M, the coordinate of point M is 0, 19 over 5. So, find the obtuse angle in degrees that the tangent to F at point D makes with the positive direction of the horizontal. Okay, so let's find, well, we know the gradient M is equal to tan of theta. And we want to find that theta, that angle. So we want to just find the gradient of the tangent at point D. Well, we know that this is your gradient, which is negative 6 over 5. So we can say negative 6 over 5 equals tan theta. So if we solve that, so solve negative 6 over 5, negative 6 over 5 equals tan theta, or tan x, let's call, comma x, where we want x to be between, because it's an obtuse angle, we want it at least from 0 to 2 pi. Or no, actually, to form an obtuse angle, we want the domain to be from 0 to pi, actually. So 0, that's equal to pi. So we get x equals this, but that's in radians, and we want it in degrees, so we'll take this and multiply it by 180 over pi. That gives us 192 point. So to one decimal place, your theta, the obtuse angle, is 192.8 degrees. Okay. The graph has two regions. The first region is, the graph has two regions. The first region is bounded by the graph of F and the tangent at point D. Okay, so what they're saying is this part over here. So the first, okay, let me just, so we're saying this part over here is, that's what we're, so that's, the first region is bounded by the graph of F and the tangent D. The second region is bounded by the graph of F, the tangent F, and at point D, and the horizontal axis. So over here, this little part over here. This little part over here. Okay. Find the total area of the two regions correct for their small place. Okay. So, what I'm going to do is, well, we know that the point of, this is supposed to, by the way, to be 0. It's supposed to actually be, so point intersect point 19 over 5, so 0, 19 over 5, and this value over here is supposed to be 3. What is this supposed to be? Yeah. What is this supposed to? So it's supposed to equal 3. Subbing, okay. So if I sub in 3, so f on 3, I get 1 over 5. So this part is 1 over 5. So if I, yeah, so is that true? So wait. To double check, what I'm going to do is I'm going to solve where f of x intersects the graph first, which the graph is this one over here. Alright, we'll take this one there. comma x. So, okay, and we say f of 0 and f of 3. Okay, so we can say from the first, okay, to write it because it's 3 marks, what we want is that the area is equal to the integral, the first part. So from 0 to 3, 0 to 3 of the linear line, which is, in this case, 19 minus over 5 minus 6x over 5 minus your f of x, your function dx. So we'll get that area. Now to get this area over here, what do we do? Well, okay. So if we calculate this area over here, what can we find? I'm just gonna rub this part over here. And okay, so we're saying this line goes like this, something like that. Okay, so to calculate this area, if we say the integral, okay, let me just actually draw this. So this is your straight line, and this is the graph of, goes like that. And then we get this. Okay, so, and we want to find the integral from there to there. So it would be okay, well, we can say this is not the best representation actually. Let me just think about it. Okay, so if we have this graph going on a straight line, and this graph's going like this, and this is, okay, we can say to find this area over here, we can first say that from this is, by the way, this point is 3. We can say that from 3 to this value, so from, okay, we can say, how can we do this? We can say, if we find the point of intersection over here, so this point over here, which is where f of x equals 0, where we want to, okay, so let's say solve f of x equals 0, comma x, and we get this yuck number. So, okay, that number, that x is over here, and this one's at 3. So we can say that 0 to 3, so we can say maybe the integral from 3 to that big number, we'll call it x. The upper function, which is that linear line, which was 19, blah, 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 minus that, minus your f of x. Okay, that would work. So let's try that. Let's write over here. So we can say plus your integral from 3 to, if I'm going to write this, so it's going to be, so 2 plus 2 over here, and it'll be 3 to the power of third times 2 over third. Okay, and I'm going to make this little, oops, I'm going to make this little, all right, like this, and put it over here. And so we're saying that to that of 19 minus 6x, like over 5 minus f of x, the function f of x dx. Okay, so that will give us that area, little area. And to calculate this area over here, it will just be, yeah, the integral from the value of x to this point, which is with where the straight line y equal, oh, okay, this is such a long question. If we take this and we let it equal to 0, and we want to solve for answer, comma x, so we get 19 over 6. So we can say that from x to 19 over 6 of the function 16 over 19 over, so, okay, let's write that. So it'll be, all right, plus, we can say plus this big function over here. So I'm going to take this over here, I'm gonna copy and paste it over here. 2 19 over 16, 19 over 6 of the function just 19 over 5 minus 6x over 5 dx equals, wow, let's see what that is equal to. So we're saying the integral from 0, 3 of this function over here, so let me take this, Control C, this function minus f of x dx plus the integral from 3 to this value over here. So if I copy this, we get this again. So we copy this minus f of x dx plus the integral of this upper function here, copy, I copied the whole thing, to 19 over 6. So 19 over 6 of the function, this function over here. So copy that, put it over here, comma x, equals 2.70. To 4 decimal places, that will be 2.7015 units squared. Wow, that was a long question. Very long question. Okay, 3 marks. Okay, question 2. Sally is using graph sketching software to design a landscape of 4 hills, blah, blah, blah. She starts by using the square root function h1, h and h2 to model the shapes of the 4 hills. Okay, we can see that. The rule of the function h of x is this. Okay, state the maximal domain. Okay, we know that maximal domain. I'm just going to use my calculator. So Control N and delete this and go. I'm just going to write domain of the function root 2 minus x. Oh, comma x, I'm supposed to write, comma x. So it's from your domain, so dom of h is from negative infinity to 2 inclusive. Next question. The rule of the function h of 1 is obtained by reflecting the graph of h in the vertical axis. State the rule. Okay, so what we're saying is that to get h1 of x, we've just said that h minus x, that's what we've done. So we've reflected on the vertical axis, which would equal the square root of 2 minus x, which is equal to, therefore your h1 of x is equal to x plus 2. Okay, that's your rule. The rule for the function this, right, the sequence of transforms that map the graph of h to h on 2. So h on h is, what was it originally? It was root 2 minus x. So what's happened is okay, we can see that there is a dilation by a factor of 2 parallel to the y-axis. Or you can say, there's another way to write it, we can say a dilation by a factor of 2 from the x-axis. So they're the same. And then what we've seen a translation. And this translation is, alright, so if they've, okay, let's say if they added -1. So let's say they said that they've translated x minus 1 to the right. What would happen is, we're saying 2 minus x minus 1, 2 minus x plus 1, 3 minus x. Okay, so what they've done is they've translated 1 unit to the right. So we can say translation 1 unit to the right, or to the positive x-axis. Okay, that's that. That's your answers. That should give you 2 marks. Okay, done with that. Okay, let's go to the next question. Okay, let t, okay, it says let T1 be a transformation that maps, it means that transforms the graph of h 2, so we want from h of x to h2 of x. Find the one set of possible values for a and b and c. So first what I'm going to do is I'm going to expand this out. So to expand it, I know that this is your x and this is your y. Okay, so we can say that it's saying as a of x plus c equals x dash and by plus d equals y dash. So if we solve for x for the first one, so we can say x is equal to x dash minus c all over a, and y equals y dash minus d all over b. Subbing that into h of x, which h of x was root 2 minus x, so root 2 minus x, we're saying that y dash minus d over b is equal to the square root of 2 minus x dash minus c over a. Okay, expanding this on my calculator, so I'm just going to make this smaller. Okay, expanding this on my calculator. Okay, and solving for y. So what we want to do is go and solve, and we are saying that, let's say y minus d over b equals the square root of 2 minus x minus c all over a. Oops, x minus c all over a. All right, and we want to solve for y, which gives us this ugly equation. So, but, okay, so we're saying this is what it is. So y, so it's y equals b times, it could be written as negative x plus 2a plus c all over a plus d. Okay, so what we want to do is, because we know h2 of x, so h2 of x is 2, 3 minus x. So your value of b is 2. At least that's, okay, we can write that here. Your value of b is equal to 2. What else do we know? Well, your d value, which is 0 here, so we can say d is here 0. What else can we say? If we equate, okay, this, that. Okay, if we equate the inner function, so this, so 2a plus c is equal to 3. Wait, that's wrong. Yeah. Okay, so we can, what about if we so what we want to do is, we're saying normally the graph, so if a equals 1, so if a equals 1, it will become negative x in the inside will be plus 2 plus c all over, okay, and we can say that 2 plus c must actually equal to the value of here, which is 3, which is c equals 1. Is that right? So therefore, c is also equal to 1. All right, I think those are your answers, because that's one set of possible. There's actually many ways you can do it, but yeah, this is the most easiest way I got. So yeah, these are your answers. So just let me rewrite them. So a is equal to 1, b equals 2, c equals 1, and d equals 0. Okay, find the value of x for which the slope of, so it says, find the value of x for which the slope of the hill defined by the function h of x is equal to the slope of a hill defined by this. Okay, so what we're trying to find is h dash of x must equal h2 dash of x. And we want to solve for x. Let's do that. So I'm going to go over here and say, okay. Okay. this derivative of this function, which is equal to the derivative of h2x, which is 2, okay, would be 2 root 3 minus x, enter, and we solve this answer equals comma x, so we get x equals 5. So find the value of x, for which the slope of the hill defined by the function here is equal to this. Okay, 1 mark, so yeah, x is equal to 513. That's your answer. Sally decides to use a quadratic function h3, okay, so a new function h3, to model the shape of the 4th hill in her landscape. Find the rule for h3, a quadratic function with a stationary point of this and which passes through this. Okay, so we can say that, let's say this quadratic function is, so it's h3, so h3 of x, which let's say is a x squared plus bx plus c. Well, I know that the 2 points is 4, 6, and 2, 5. So if we solve, when f2 equals 2, not f, h3. So if we say h3 of 2 equals 2, also h3 of 4 equals 6, and also that h3 dash of 4, because it's a stationary point, must equal 0. So if we solve those, we would get, okay, so we would get our values of a equals, b equals, and c equals. Okay, let's do that. So what we're saying is, if we define a function, so let's say h3 of x is defined from a times x squared, so x squared plus b times x plus c, plus c. So, and what we want to do is, we want to go on algebra, solve systems of equation, and we have 3 equations, and we want to solve for a, b, and c. So we know the first one is when h3 is 2, and it should equal to 3. We also know that h3 of 4 should equal to 6. And we also know that the derivative of, with respect of x of h3 of x must equal 0, given that x is equal to 4. Okay, we get our values. A equals -3/4, so -3/4, b is equal to 6, and c is equal to -6. All right. Sally believes that the function h3 is closely related to the inverse of h. Find the domain and the rule of the function h inverse the inverse of h of x. Okay, so for the rule of the inverse, so it should be find the rule of the inverse of h of this. Okay, so the rule for this is okay, so what I can do, it's only 2 marks, so I only have to give the domain, and what I can do is, okay, let's just say your rule, we can all do these by calculator. So we know the function is this. Let me just put it over here. And let's define this function as what? F of x. So f of x is given. F of x is this. We define the function this. And what we want is the inverse. So if we want the inverse, is just solve f of y equals x, comma y. And we get this. 2x, so y equals, so it would be, but in this case, it will be h inverse of x is equal to 2 minus x squared. And the domain, so the domain of the inverse, so domain of h inverse of x, h inverse is the domain, or actually the range of, it's equal to the range of h. So how can we think about this? Well, we're saying, okay, so if I was saying that it's been, okay, negative x plus 2 equals x equals 2. So it's been translated 1 unit, and it goes like this. So your range is still 0 to infinity. So it's from 0 inclusive to infinity. So your dom of h inverse of this is actually 0 to infinity. That's your answer. Find the domain and the range. Okay. Anything else? So find the domain of this. Have I done it right? Yep, looks right. Consider the function t2 equals this. Does this transformation above map, so change the function h into the function of h3? Give you a reason, justify your answer. Well, first let's expand that thing. So this, we're saying this is x and y. Okay, so if that's y, we're saying x dash is equal to y plus 4, and y dash is equal to x plus 4. Now, we find y is equal to x dash minus 4, and x is equal to y dash minus 4. Now, knowing this is I'm going to sub it into the function h of x. So I can say h of x is, okay, root 2 minus x, so it will be y dash minus 4 equals the square root of 2 minus, okay, what am I doing? Okay, what am I doing? So this will be y dash minus 4 inside, and here will be x dash, so it'll be x dash minus 4. And so if we square x dash minus 4 is equal to 2 minus 2 minus y dash plus 4, and we can say that x dash minus 4 squared minus 6 equals negative y dash, which means that your y dash is just 6 minus x dash minus 4 squared. So we got this. Okay, so that's the transformation above map, so change the graph of, so wait, does the transformation above so change the graph for the function f into the function of h3. What's h3 actually? Again, what was h3? h3 was what's h3 again? h3, so that's h2. So blah blah. Okay, h3. Okay, h3 is that parabola. So okay, so it's that parabola and it goes down. Okay, what else? Okay, so it has a 4 and a 6, which is right. The turning point is 4, 6, and it's a negative price. So the rule's right, but what about the domain? Okay, for the domain of this, well, okay, the domain of h3 over here, so the domain of h3 over here is h3 over x. So the domain of h3 is from 2, so wait, is it, yeah, so 2 to 4. That's where the domain is of h3. And the domain, so h3 domain is from 2 to 4. And what about the domain for this function over here? Well, the domain for your y dash, which is your h, is just x is greater to or equal to 4. The domains are not the same, so the rules are the same, but the domains are different. Domains are different. Therefore, or hence, the function so T2 does not map the function h onto h3. I hope that's right, is it? I'm just gonna highlight this over here. Okay. Okay, let's move on to the next question. All right, that's good. Let's do this. So the function p of x is this, and q of x is defined. Find the area bounded by the graph of p of x, blah, blah, blah. Okay, so what I'm going to do is I'm going to control n, and okay, I'm going to define function. So we're going to define p of x. Oops, so p of x is 2 times 1 plus, so 1 minus e to the minus x, and q of x is from 2 times 1 plus e to the negative x. Okay, now we know, so the area bounded by the graph is, I have no idea how they look, so I'm just going to say p of x and q of x. So this is p of x and q of x. And we want to find the area bounded by them. So find, and also x, if we draw a relation, so at also x equals 0, and also at x equals 1. So we want to find this part over here. So to do that, okay, we'll write, we want to find the area from 0 to 1. So 0 to 1, the upper function for this is q of x. So q of x minus p of x dx is equal, let's do that over here. So we're saying from 0 to 1, q of x, okay, minus p of x, so minus p on x. So that gives us, find the area, blah, blah, blah. Okay, let's write this as a whole. So it will be, we're saying 9e minus 8 e to the negative 1 all over 2. Next question. State if p and q are strictly increasing, decreasing. So for p of x and q of x, let's find if they're strictly decreasing. If we look at the graph, let's look at p of x first. So p of x is the blue graph. So we can see that it's, well, wait. So p of x is this, and this is that. So to find its nature, so wait, if we go zoom out a little bit. Okay. So, have I done anything wrong? Oh my god! P of x, okay, no, P of x, I forgot to put a 2 here. Okay, so your value here changes. It's this one. Oh no, okay. So let me just rub the first question, the answer for the first question, and we're saying that for e negative 1, e minus 1, okay? So, okay, so p of x should change, so, okay. So if we zoom in, now, so we can see that p of x is, if you look at it here, okay. If we look at p of x, if we look at p over x here, what can we see? Well, we can see that p of x is the blue graph. We can see that it's strictly increasing and then starts to become 0. But it's strictly increasing. So we can say that p of x strictly increases. And for q of x is strictly decreasing. So we can say strictly decreasing. All right. Let's go to the next question. Find the rules for the function p, okay, inverse of an inverse. Okay, so it's just 2 marks. So let's find this, and let's find q inverse of x. Very easy. Let's use our calculator, just the rules. So go over here and say, solve. Let's do p of x. So it'll be p y equals x comma y. And we get this. So we can say it's log e negative 2 x minus 2. Same for q of x, so I'm just going to put q over here. That gives us log e 2 x minus 2. Let's see. Let point A be the intersection between p of x and the inverse of q, and let p be this and that. Okay, find the coordinates of A. So the coordinates of A is this. Find the coordinates of B. Okay, to do that is, so q of x, so we want to solve q of x equaling the inverse of p, which is this one over here. So if I take this and put it over here, comma x which gives us this value over here, which is, so it says find the coordinates correct to 3 decimal places. So I'm just going to write this over here. So we're saying 1.805. And if I say Q, this value over here, we get 2 point, so we want only 3 decimals, so 2.329. So that's coordinate of B. Write down the equation of the line that passes through the point A and B in the form of y equals mx plus c. Give any appropriate values correct to 3 decimal places. So write the equation of the line that passes through these. Okay, so well, if we know, okay, let's find the gradient. So for the gradient, just let's find the gradient. So the gradient is, because we know the 2 points, so the first, if I say 2.329 minus 1.805, 1.805 minus 2.329, it gives us -1. So your value, we can say y equals -x plus a value of c. So to calculate that c value, okay, what we're going to do is, we know normally, okay, it's y minus the value of your intercept, so it's this one over here, equals -1 times x minus your value over here, and we get this. And then we want to solve this function, so answer for y. Control enter. Wait, write down the equation that passes through A and B in the form of this. So, because it passes through, well, we know it passes through this. Oh, what am I doing? Okay, if I know that the y value, which was over here, equals to -x plus c, and our value of x is over here, we can say x equals this, and we want to solve answer for c. So 4.13, okay, 4.13, okay, so it's, your c value is that, just double checking, so we can say your c value is plus 4 point, so 3 decimal places, it's 134. Okay, write the equation that passes through this in the point correct 3 decimal places. It looks right. The function is a product of the function p and q, which is this. Show that p of okay, so we need to show, to do that, we just need to, okay, well, p of x is what? If I go up, p of x is 2, 1 minus, so 1 minus. So we're saying 1 minus 2e, wait, 1 minus 2, okay, wait, 1, so 2, 1 minus e negative x, so e negative x, and we put a 2 over here, is that right? But that 2 is not supposed to be down there. Just e negative x, e negative x. So, yep, multiplied by, again, 2, so we can just say that's 4, 1 plus e negative x. Multiplying that all, so it'll be 1 plus e negative x minus e negative x minus e negative x, so minus 2x, which is 4, 1. These cancel out anyway, so it'll be negative e negative 2x. Yeah, we've shown that's that. Okay, set the domain and range of r of x. So to do that, it is, okay, we can say domain, dom of r, and the range of r equals, so by calculator, if I know that r of x, so r of x is given as p of x times q of x. So I know that, and so we can say domain of r of x, comma x, comma x. Okay, no. Oh, so r comma x is negative infinity to 3, so it's all reals. What about the range? To find the range, I'm just going to sketch it, so we can say r of x. Okay, we get negative infinity 2, 1, 2, 3, 4, 4. Looks 4. Yeah, the asymptote from 4. So we can say negative infinity 4 non-inclusive. Find the rule of the function r of s. Give your answer in this. Okay, to do that, it's only 1 mark. So I will say solve r y equals x, comma y. We get this. So we want to get it in that form. So we could say r inverse of x is equal to half natural log, which is just log e. We need to get it in this form. So okay, log e, we're saying minus 4 x minus 4. Okay, so but if we say 4 minus x, 4 minus x, and say, and that this becomes positive, which r minus of x is equal to the form of half log e 2 squared over 2 squared minus x. That's the answer. Clearly state the equation. So clearly state the equation of line that the points of intersection between the function r and its inverse both lie in. Wait, clearly state the equation of the line that passes, that the points of intersection between the pass. Okay, so wait, if r and this, if we're saying, okay, so wait, so let's do that. So what we're saying is we want to solve where this function over here equals r of x, comma x, and we get ugly function, very ugly, and we want to, so we get 2 parts. Okay, so let's say r of this function over here we get is just 0, and r of this function over here is 3.9, and so the gradient is let's say this value minus 0, and this one's also 0. We can say over, so gradient is wait, so minus 0, so this minus 0 minus this, and if we take this, put it over 2, it's just equal to 1, 0.99. So clearly state the equation of point the lines of intersection equal. Okay, so if we know that the gradient is that, so we can say that y minus well, we know that the, okay, what do we know? Well, this is your y equals this x minus this, x minus that, and yeah, so solve your answer, comma y equals, oh yuck. So okay, y equals 0.9, so just say 1 if we're going to make sure, because it says clearly state the equation, so it's a whole number, so it's 1 x minus this number to the negative 4, which is just 0. Anything, so we're saying it's very, very small, which is just 0. So we're saying 1 times x, which is just y equals x. Is that right? Y equals x. Wait, this is the equation of line that finds the intersection between the function and its inverse both lie in. Yeah, looks right. Find the coordinates of the point of intersection. So find the coordinates of the points of intersection between the function r and its inverse. Give your answer to this. Okay, didn't we just do that? Okay, if we go up here, so the first one was this, which was, just say this, it's 0 and 0, because this is very, it's like 0. It's such a small number, so negligible, so it's, we're saying your 2, so it will be 0, 0, and the next one is, so to 3 decimal places. So this one, which is, so on 3.9, okay, wait, 3.99999. So we're saying 3.999. Wait, is that right? 3.999, and this is your y value. Is that right? So 3.999. Is that your answer? Let me just double check if there's anything. Okay, we got the... Let me just double check. So what we're saying is we want to solve where r of x equals your inverse, which was... Oh, so okay, we got these. These are the points, and if it said r of x... Let me just try this. Copy this and just say this function given this, which will give us 3 point... Okay, so yeah, looks right. Question 4. A bakery sells glazed donuts. The probability density that describes the thickness of a glazed donut is this. Show that the mean thickness of the glazed donut is this. So, to show that the mean, we're just saying the integral from 0 to 6 of x times f of x dx is equal to, by doing this on the calculator, so we're saying from 0 to 6 x times f of x. Oh, we haven't even... Okay, wait. Control N and make a new. Okay, what we want to do is we want to define f of x as... negative 108, so 108 times x to the power of 3 minus 6 squared. Okay, so we're saying from 0 to 6 x times f of x comma x, which is 18 over 5, which is true. 18 over 5, which is equal to your mean, which is your mean value. Next question. Find the standard deviation of the thickness of the glazed donut, blah, blah, blah. Okay, so we note that the variance is... Okay, it's the integral. So we note the variance is from 0 to 6 of x minus your mean value squared of f of x dx. And we can take the square root of the thing. Okay, so we're saying square root of 0 to 6 of x minus your mean value, which is this. We want to square roll times f of x dx. Okay, we get this, but we want to square root it to get your standard deviation. So your standard deviation is square root your answer, 6 over 5. Find the median thickness of the glazed donut in millimeters. Okay, so we're saying from 0 to x, which is your medium, of the function f of x dx should equal half. So x should equal to, we're saying, okay, from 0 to a value of x. Oh, not x, that's not x. Let's say a value of a. Let me just take that out and put a. And of the function f of x, f of x dx should equal to half. So if we solve answer comma a, we get a equal to this and that. But we know a is between 0 to 6, so a is equal to 3 point this to correct to 4 decimal places. That will be, it'll be a equals your median is equal to 3.68 to 4 decimal, so 3.6856. Find the probability that the thickness of a glaze on a randomly selected donut. Find the probability that the thickness of a glaze on a randomly selected donut is greater than this. So we want to find the probability that x is greater than 2, given that the thickness of the glaze, that the thickness is less than the median. So x is less than the median, which was 3.6856. So find the probability is greater than this. Okay, so I know for a fact, that, so 2 is here, it goes to infinity, and 3 is over here. So the intersection, so we can say, rewrite this as probability as 2 is between x between 3.6856 all over the probability of x is less than 3.6856. Putting that in my calculator, so, first, actually, divide, let's put division suit in here. So we're saying that the integral of, so 2 to your median value, which is over here. Yep, so 2 to this value of f of x dx, and we want to find the integral for where it's where it's less than this. So the most least value we can go is, I think, 0. So it's 0, 0, oops, and put this value over here of f of x. So your answer is 0. So two decimal is 0.78. Next question. The bakery also sells donuts with a custard filling. The amount of custard filling in a custard donut has a normal distribution with this and a standard deviation this. Then the probability that a randomly selected custard donut has between 25 and this. So we want to find the probability as, so a random selected has between 21.5 and this custard donut. Has between, so we can say that it's between these. Is that how you write it? Find the probability that a random custard donut has between this and this. Correct 4 decimal places. So using the menu probability distribution, and we're going to use normal CDF. 21.5. Your upper bound is 25. Your lower bound, your mean value is 22, and your standard deviation is 2. Is 0. So your answer is, to for this much, 0.5319. Next question. The bakery also sells donuts with a jam filling. The amount of jam filling in a donut follows a normal distribution. It is known that on average, 95% of the jam donuts. So it is known that on average 90% of the. So I'm just going to draw a normal distribution here to make my life easier. Okay, so it is known that on average 95% of the donuts have at least 15.1. So wait. Your mean, we know that the. All right. So let's say. Okay, 15.1. Okay, so let's say this value over here is 15.1, and we know that 95% have at least greater than that. So this all over is 0.95, and 10% of the donuts have more than this. So somewhere around here of 23.9, we have 0.1. So yeah, the record also says the amount of filling to do follows a number to knows that on average is this. Okay, find a minute standard deviation correct to the nearest of this. Okay, so to do this question, well, okay, we know that the probability of x is greater or equal to 15.1 is equal to 0.95. And we also know that the probability as x is greater or equal to 23.9 is equal to 0.1. Now, I can change all those values, so probability, so we can rewrite as z is greater than 15.1 minus your mean value over your standard deviation of 0.95. And the other one's probability at z is greater or equal to 23.9 minus your mean value over standard deviation 0.1. Okay, let me make this much smaller. With knowing this, we can say we get two equations. So we get this. Oops. Okay, we get 1 and 2. These are your two equations. So, what can we do? Well, okay, so we can write z is greater or equal to 15.1 minus this. Oh, no, actually. We can write it as 15.1 minus the this equals. Okay, so if we use our calculator, go on probability distribution, and we go to inverse normal. Was it? Okay, inverse normal, I think. Inverse normal. So area. Wait, have I done? Wait. Okay, wait. We've done... Okay, something's wrong with this. Okay, before we do that... Okay, let's do something. Let's first... Okay, let me just rub everything out. Okay, this question's a pain. Okay. So, let me just write... Let me make it smaller. Okay. So we're saying that the probability as x is greater or equal to 15.1 is 0.95. Now, if we change that up, so like saying as the probability x is less or we can say equal, yeah, less or equal, who cares? If we say less or equal to 15.1, we'll get 0.05. That's your first equation we can use, and we know we do the same for the other one, so probability as x is less or equal to 23.9 should equal 0.9. Now, yes, here, okay, we can say that your probability of z is less or equal to 50.1 minus your mean value over your standard deviation is equal to 0.05, and your probability that z is less or equal to 23.9 minus your this over this is equal to 0.9. Now, we'll get 15.1 minus this omega equals some value. So if we go on menu, probability, distributions, inverse norm. So our area is 0.05. And our, we don't know our mean value. So wait, what have I done here? We don't know those values. So what else? Probability distribution. No, CDF. Okay, have a not inverse binomial. Okay. So wasn't it inverse norm? And we don't know those. Okay, yeah. What am I doing? Yeah. 0 to 1, because it's the normal distribution, which is 0 to 1. Okay. This and your area was 0.05 equals this. So this is 1.6448. And the next value, I'm just going to make this smaller. Oh, this is such a draining exam. Wow. Okay. And our next value we know is 23.9 minus your mean over your standard deviation is equal to... take this, and we're now putting 0.9. So we get 1.2815. Knowing these two values, okay, that's good. Now we can just use simultaneous equations to solve for these. So your mean value, so your mean is equal to, and this is equal to what? Let's go to algebra, solve systems of equations of two equations for, let's say, Q is your mean and O is your this. Okay, so we're saying that for the first one, 15.1 minus Q over O is equal to this value over here. And if I copy this all again, put over here, but this one's now 23.9, and delete this and put this over here, we'll get, okay, so your mean value is 20, okay, to correct to the nearest mirror, so it's 20, and your standard deviation is 3. A random selection of bakery donuts is packed on the boxes. The proportion of custard donuts is the proportion of donuts as made in the VS. Find the expected value, so expect the number of custard donuts in a box of 25. So expected, say x is equal to 25 times 0.44, which is equal to, so 25 times 0.44, 11. So that's our expected. Find the probability that in a box of 25 donuts there are at most, so probability that in a box of 20 donuts there at most, so we want x is some less than or equal to 7. I'm just going to use a binomial to give you an answer. Okay, that's what we're saying. So x is less or equal to, is that true? Find the probability that in a box of 25 donuts there are at most. Okay, yeah, looks right. So using our calculator, I know that if we go to probability distributions, and this is binomial CDF, number of trials is 25 donuts. Your probability of success is 0.44. Your lower bound is 0 and your upper bound is 7. Giving you answer is 0. To correct the 4 decimal, so 0.0773. Find the minimum number of donuts required. So find the minimum donuts required to ensure that the probability of having at least 12 custard donuts is greater than 0.9. Okay. This can be rewritten as probably as x is less or equal to 11 less than 0.1. Is that true? So if we have 12 over here, and let's say that was 0.9, and okay, less than that, we'll get 0.1. Okay, looks true. So what can we say? Well, if we go to menu, probability, distributions, and we go on inverse binomial n, cumulative probability is 0.1. Your probability of success is, again, 0.44. Probably, or x value is 11. And we get 35. So n equals 35. The bakery staff want to determine whether the customers think of the donuts as delicious. If a random sample of 64, 30 customers that bakery do delicious. Okay, so 30 so out of 64, 30 like them. If P is the random variable representing sample proportion of 64, find the standard deviation. Okay, well, okay, what is the standard deviation of this? I know that the standard deviation of, okay, wait. So what is the standard deviation of P hat? I'm just going to look at the formula sheet. So we want the standard deviation. It is as, so as d of P hat, it's P minus 1 minus P over N. Because, so that should equal, so let's go on our calculator. So we're saying P, which is, square root actually. So square root P. So our P value over here is, so what's 30 over 64? So 30 over 64 times 34 over 64, and our value of n is 64 customers. That gives us 0.0624. Is that right? Yep. Find an approximate 95% confidence interval. Okay, that's easy. So go menu, statistics, confidence interval, and we want 1 prop z. Well, we want 95%. Okay, so we know our x value of success is what? So there are 30 customers, and our n value is 64, giving us our answer as, okay, so it's to how many 4 decimal places? So it's 0.3465, 0.5910. Interpret the confidence interval you found in G, this answer, in relation to the proportion of customers who said that the bakery donuts are delicious. Wait, interpret the confidence interval. Interpret the confidence interval you found in part G in relation to the proportion of this. So this, it means pretty much the confidence interval, 95%, means that we are certain, so we can say okay. How would you, so I don't know what to ask, so the confidence interval, so the confidence interval tells us that we are certain that the 30 out of the 64 people who love donuts, who said bakery donuts are delicious. So the confidence interval tells us that we are certain that 30 out of 6 people who said that are in between the value of, okay, so we have these confidence intervals. So if I can tell that you found the relationship. So, okay. The confidence interval tells us that we are certain that the 30 out of 64 people who said bakery donuts are delicious are in between the values of probability of 0.3465 to 0.5910. I don't know, something like that. I'm so unsure what the question's telling me. Interpret the confidence we found in relation to partial questioners who said that. Okay, confidence tells us that we're certain that 30 out of delicious are of this. So it tells us also that it means, if we're going to interpret this, is if we take these values and multiply them by the 64. So the lowest customer, so that's around, we're saying that 22 to 22 till, we bring the upper value times 64. 38. So what we're saying is we are certain that between 22, so we take 22 individuals between 22 individuals and 38 individuals, in between those numbers, that we're certain that 95% of those customers will love the donuts, that think of the donuts are delicious. So yeah, we are certain by 95%. Okay. Oh, is this the last question? Looks okay, perfect. A spring of weight, so attached, suspended from stand. The base of the weight is 40 centimeters. So, yep, so 40 centimeters. Okay, yeah. Okay, so it's 40 centimeters above the bench. Yep, this is your bench. The spring is released and moves vertically up and down the surface, such as that the height of the base is way above the bench over the 10 seconds it's given by. So it's 10 seconds. Okay, we're given the function where t is measured in second, a graph of. Okay, so what's happened is that the spring, it goes like this. This goes up and down, starts decreasing, and so that's what the graph is telling us. So let's look at the question. So what I'm gonna do is the dash curve B1 lies above the graph of H, and the dash curve B2. So what I'm gonna do first is the dash curve B1 lies above the graph of H, and the dash line B2 lies below the H. Find the point B1 and B2. Okay, the dash B2 has this equation. State the equation of B2. So B2 of t is equal to what? Well, we can say that, so this is B2, and say we reflect it, here's 0, reflect it along the x-axis, so it will be, say this is 40, negative 40, it pretty much would look like something like this. Wait, if we flip that around, it actually would look like this if we flip it around, and we actually plus 40 to make it back to 0 to get this. So we'll say it will be negative 20e negative 2 over 5 minus 20, but we also want to add that 40, translation of 40 up, so it will equal to negative 20e negative 2 over 5 plus 20. Okay, next is find the average value of the weight in find the average value of the height in centimeters of the base of the weight above the bench over the 10 seconds. So easy. So the average value is 1/10 integral from 0 to 10 of the height, which is h on t dt. So which is, let's define h. So control n this. H on t is defined as 20 e negative t over 5 times cos 2 pi times t plus 20. So knowing that, what we're saying is, so we're knowing that, we're saying that the integral from 0 to 10 of 1/10 here, so we don't want to forget that 1 on 10, of the function h on t with respect on dt is equal to this ugly function. So to simplify this function, it is pretty much, so find the average value to 2 decimal places, it will be 20, so it will be 20.01 centimeters. All right, this is the last page. Okay, write down the rule of the derivative of h. Okay, very easy. So h on t is equal to, so the derivative is with respect of d on t of h on t. So h on t is this ugly function. So we're just going to write negative 4e negative 2 cos 2 pi t minus 40 e, okay, minus 40 pi, we all forgot pi, wait, it'll be 40 pi e negative 2 sine 2 pi t. Okay, next question. Find the time in seconds that and the height above the surface in centimeters of the point of the maximum positive rate of change over the interval of this. Find the coordinate. Okay, to do that, what we're saying is positive rate of change. So we're trying to find where h on t is at its maximum. So where it's at its maximum value. Okay, so it's active. So I think just this question, I'm going to do it on calculator. So wait. To do that, so what I'm going to do is we want to find h dash dash t equals 0, where t is between 0 t to 10. So if I'm just going to graph this because I cannot be bothered actually. So what's the derivative of h on t? Oh, no, okay. Why have I done here? So it's supposed to h on x. Okay, we get, okay. We want to make sure it's from 0 to x to 10. Okay, so that will give us, all right. So your maximum value would be the first one because it's the highest. So if I go up, it's this one, which is, if I go graph trade maximum value, it's this. That's your coordinate. Wait, write your answer into coordinate pair. Okay, so it's to what? To 1 decimal place. So it's 0.7108. Okay. I hope it's, wait, if I copy this, because I need to get in decimal, so is it just 1/8 here? If I copy this and paste it over here. Oh yeah, it's just 1/8, okay. 1/8. Move on to the next question. Determine the total distance traveled by the base of the weight over the first 2 seconds of its motion. So what we want to find is if we rub everything out of here, okay, what we want to find over its 2-second motion. So 2 seconds is over here. Oh, yuck. Oops, okay. So 2 seconds of its motion is over here. So the graph pretty much goes like this. It's Goes down, up, down, up, and we want to find that distance. So we know, okay, so if we look at the graph over here, and I want to just zoom out, it makes it easier. So zoom it out. Okay, wait. Let me just make it easier by going menu, Windows settings. Okay, so let's say our minimum is 0, our max value is 10, and we're going by 1. Your Y minimum is 0, your max is 40. Wait, max is 40. Okay, not 40, let's say 200. And your Y scale is, let's say by 10s. Okay, so we get this. This is much nicer. So, oh, no. What am I doing? H on T, not the derivative of H on T. Okay, that's a problem. So we want H on T, H on X, H on X. H on X. Well, okay, I can't take that. Okay, so I probably have to. Okay, so we want to find H on X, where it's from 0, X, 10, and we get this. Okay, so the distance is, if we're gonna calculate this, is we want to find this maximum value. So say this is 1, this is 2, so this 2 maximum. If we find these 2 maximum, so that's this and that's that. And let's find 2 minimum values. So our minimum, our minimum values is this. Oh, wait, what's happened? Oh, this is wrong. Wait. Maximum is this point. Okay, so this point's that. We want to find that minimum value. So analyze graph, minimum, this point. We also want to, okay, is that it? Wow, so that's 1 and that's 2. So we need to find that also minimum. So if we go minimum, okay. So if we find, okay, the distance between, so 40 minus, oh yuck, okay. So 40 minus 1.89, so we can say 40 minus 1.89, 1.89 plus, that's the distance, so this is that distance, plus 1.89 to 36.4. So 36.4 minus 1.89. 36.4 was it? Minus 1.89. Plus, so we've done that up. Okay, now we're saying 36.4 to the value, this value. So 36.4 minus 5.18. So 36.4 minus minus 5.18. 5.18. Okay, and then we're here, so we just want to find 33.4 minus 1.8. Okay, plus 33.4, minus, okay, 5.18. Is that right? So minus 5.18, so this to that equals 132, so it's, okay, that's your total distance traveled by the bicycle car is, in centimeters, it's 132 centimeters. That was a actual quite, like, it felt very long, this exam, I'm not gonna lie. There was some questions like that took very long. So yeah, this exam was, I'd say it's all right. It's not too bad, but yeah, it's a very long exam. It has questions that take you very long to answer. So hope you guys enjoyed this video, and make sure to like and subscribe and share with your friends. Have a good day.